Hey guys, welcome to Unit 2, Lesson 4. Today we're really going to focus on just solving triangles. So this should be a pretty easy lesson, but the difficult part is we're going to draw on a lot of the new stuff that we talked about in Lesson 3 and the calculator problems, things like that. So this is going to give us a lot more freedom instead of just doing like 30, 60, 90-degree triangles or 44 or 45, 45, 90-degree triangles. This literally opens it up for anything. Okay, so the first thing I want you to do, and we've talked about this before, just kind of decode what you have. So it doesn't matter where you put angle A and angle B, just as long as angle C is a 90-degree angle. So I'm just going to put angle A and angle B down here. That you will not get anything mixed up or messed up as long as you put little a, side A, across from angle A, and side B across from angle B and side C opposite of angle C. As long as you have that, then we can just kind of fill in. So I know that, let's go ahead and put this in. This angle right here is 28 degrees, 40 minutes. So I got that. And I also know that angle A, or sorry, side length A is 25.3 centimeters. So from here, you have a lot of leeway on what you need to do. So I know that I need to solve for a missing side length or angle A. Goodness gracious. I'm missing side length B, and I'm missing side length C. So how you get there might look different for each person. It's just whatever makes the most sense to you. So I think first thing I want to do is solve for, I don't know, like you could do a couple different things. I know that like there's 180 degrees in a triangle, but I also know that these two add up to 90 degrees. So in a right triangle, angle A plus angle B equals 90 degrees. So I think maybe I might start solving for angle A. So I'm just going to say 90 degrees minus 28 degrees, 40 minutes, and kind of go from there. We've talked about this in regards to Unit 1 test, so keep it consistent. So please do not give me angle A in decimal form because they gave you this as a degrees, minutes, and seconds. You're going to keep this as degrees, minutes, and seconds. Okay, so I have 20 minutes and 61 degrees. So I know that is my angle A. I'll go ahead and fill that in. Okay, I think maybe I want to do angle B next. So, so then I'm going to ask myself, okay, what do I have? So I have this angle and this side length, and I'm trying to find B. So I'm going to try to figure out which one do I use? Do I want to use sine, cosine, or tangent? And if you're crazy, you can use cosecant, secant, or cotangent, but that just makes things more difficult. So let's see, I have an opposite side and an adjacent side to this angle. So I'm going to use tangent. So tangent of my angle equals B over 25.3. So I would look at this as a proportion. You don't have to, but I think that makes it a little bit easier. So in that case, I'm just going to multiply both sides, both the angle, the tangent of the angle, and the side length to equal B. And so go ahead and do that. And B should give you about 13.8 centimeters. Okay, now, since we have, let's do this in a different color. Since we have this side length and this side length, we can use Pythagorean theorem to find this side length, or we could do another trig function. It's totally up to you. So let's kind of switch it up and we'll do Pythagorean theorem. So I'm going to say 13.8 squared plus 25.3 squared equals c squared. And so if you do that, C should equal about 28.8 centimeters. And once we have all those, we are done. So go ahead and try to do this next one on your own, and I will meet back and see how you do. Okay, so this one's a little bit different. I wanted to see like if you could figure it out on your own, but this was kind of a tough one. So the first thing I did, just to make it easier on myself, is to find C. I already had the side length, so I went ahead and did Pythagorean theorem to find C. So that wasn't too bad. So we've got that. That looks like a sideways angle. Okay, so the next one is I have to figure out if I want to find A or B. So I randomly just chose B, but we have to set it up. Think back to what you learned in lesson 3. So I don't have an angle. So this is going to feel really weird because this is one of the first times that you're not going to have an angle. So you're going to use the opposite over hypotenuse and fill that in, and then use that sine inverse to go backwards to find the angle. And so something else I want to point out is it doesn't matter. You could have it in decimal degrees or degrees, minutes, and seconds. Just keep it consistent either way you choose. So we found B. So finally for A, again, just to make it easy on myself, you don't have to do it this way, but I knew that A plus B equaled 90, so I subtracted B from 90, and I got 38.38 degrees. And then if you chose to do it in degrees, minutes, and seconds, I put that down as well. So again, it's just how you see it. This is personally how I saw it. Just find that way that feels most comfortable to you. Okay, the next thing we're going to do is talk about angle of elevation and depression. So I'm going to attempt to draw. It's not going to be pretty, but we will kind of go from there. Okay, so the first thing that I want to point out is we're going to have angle of elevation and depression problems. If I were you, I would look at every problem as an angle of elevation. It's a lot more easy, so I want to focus on that right now, and then we're going to get to the angle of depression and what to do with that. So notice this person, if they were looking straight ahead, it would look like this, but they're having to look up at this person. So the problem might say Mrs. Siegel is looking up at one of her students at an angle of 30 degrees. So that's going to be my angle of elevation, and that's what's going on there. So notice it's going to be a right triangle, and that's how we are going to get those values there. Okay, so we can also look at it from the student looking down to Mrs. Siegel, which is careless Mrs. Siegel, it looks like. And so we're going to do that here in just a second. I think it's confusing, so I always look at it from the perspective of the lower elevation person looking to the higher elevation person. So we'll talk about that in a second. Okay, so this is an angle of depression. So again, just like I was looking straight ahead versus looking up at an angle of 30 degrees, my student is looking straight ahead versus down at an angle of 30 degrees. So my angle of elevation is the same as their angle of depression. So think about, we have this like rectangle. Sorry, that's a hideous rectangle. Just make sure that you're putting your angle of elevation here and your angle of depression here. Now, again, you're only going to need one of them. Why I'm saying this is because a lot of people will put that 30 degrees here, and that is incorrect. Because think about, like, these are parallel and we have alternate interior. So this is not equal. And I see that mistake over and over again. So make sure that if you're going to use angle of depression, you put it in this location, not this one right here. Okay, so let's talk about how this looks in a problem. So the angle of elevation, so we're looking up from a point on the ground, is 15.5 meters from the base of a tree to the top of the tree. I'm sorry, so the angle of elevation is 60.4 degrees. Find the height of the tree. The first thing you need to do is you need to draw the picture. So go ahead and do that. I also went ahead and filled in the values. So I have my angle of elevation and I have my distance from the point on the ground to the tree. And now I have to figure out which trig function to find the height. So I have an angle and I have opposite of that angle and I have adjacent. So hopefully you're seeing that you're going to use tangent. I'm just going to set it up opposite over adjacent and then solve. So again, look at it as a proportion. So we're going to multiply those two together and I get h equals 27.3 meters. Okay, this one is an angle of depression. I want to encourage you to look at it as an angle of elevation problem. So see what you can do with that. So this is how this problem would look like from an angle of elevation. I'm just looking at it from the perspective of the building across the street 42 feet away. If you are like, that's confusing, the angle of depression would look like this. The values would be the same, so this would be 97. And then your angle is going to be right there. So be super, super careful. Oh, this is 42. Again, I don't like to do it like that, but you're more than welcome to. So if we're going to, either way, just grab what you need. So I have, again, I have an opposite side and adjacent side. I'm trying to find an angle. So we're going to use tangent again and opposite over adjacent. So I'm going to have to do that tangent inverse. I'm trying to find the angle. And I get theta equals 66.6 degrees. Okay, and that is it, guys.